Okay, we have 700 meters of fencing material and a building on one side. So basically what we can do is set up our equation. Okay, now we don't know these sides, but we know we've got 700 meters of fencing. I set up my unknown, which I'll use as the width. I could have used it as the length, but I've chosen width. So if this and this are x, we've got a rectangular field. Okay. If this and this are x, because the whole length of fence is 700 meters, we have 700 minus 2x at this point. Now we've got to determine the dimensions of the field that will enclose the largest area. So we're better off setting an equation for area. So area will be x times 700 minus 2x, simply because it's a rectangle, length times width, okay, which I'm going to multiply out to 700x minus 2x squared. Now we know it's an optimization problem. We've got to enclose the largest possible area. So what we're looking for then is a maximum area. And if we're looking for a maximum, we're looking for f dash of x equaling 0 to find us the x value. And then we'll decide whether it's a maximum or not. So first off, if f of x equals 700x minus 2x squared, simple differentiation gives us 700 minus 4x. So then, due to this solution, we are going to solve 700 minus 4x equals 0. Okay, so add 4x gives me 700 equals 4x, and therefore x will be 700 over 4. Okay, which if we simplify that to 350, 175. So now in a simple case, we know that x is 175, so we would go back up and say dimensions of the field, well, that's going to be 175, 175, and 700 minus 175, okay, which is 525 meters. Okay. Of course, we've got the same on that side of the building, but we've got dimensions of the field that will enclose the large area. Now we really, because of the level we're at, we should show that this value here would actually be a maximum. So we could either sketch, and we would see we've got quadratic at this point where x is 175 is one way. We also could do f dash dash of 175 and figure out whether that result is negative or positive. Okay, and obviously depending on whether it is, that shows whether it's a maximum or minimum. Obviously again, we could just find a value either side with the first differential and decide whether it's negative 0 positive or negative 0 or positive 0 negative. We've got the three different options if we were going to have to work out whether it actually is a maximum or not. I think in this case we're okay with just knowing that these are the dimensions of the field. Okay, so let's just check then. So if f dash of x is 700 minus 4x, then f dash dash of x will be just minus 4. Okay. Now at this point, it might seem a little confusing that we've only got -4, so we can't actually put in 175. But what this means is that the second differential will always be negative. Therefore, at this point where we know the first differential is 0, we know the second differential will be negative. It's -4, so that means we must have a maximum. And that's because our first differential will be just a linear function, a straight line, so our second differential will be a constant. So that's why in this case we probably don't need to go as far as second differentials. We know that we've got a maximum point here. So if we graph the initial function, the f of x equals 700x minus 2x squared there, that's what this would have looked like, and we know that we've got a maximum.